And so let's do maybe one, maybe two. Maybe I'll do this in a base 2 long division, and we'll be done with all this foreign base stuff. This is it. I think you've about got it. So let's set it up. So remember when we write division this way, and then we need to turn that into, you switch it around for the more traditional long division. I don't know why we have those two different ways. That's just the language of it all. No real rhyme or reason there. But you all know that we changed that, right? So in base 6, the 43 is the divisor, goes on the outside like that. All right, so let you try. How about we do a step, and then I'll do a step, and we'll go on through. What's advantageous to do right away? Do those times tables, because you don't normally know the base 6 times table. So what I'd encourage you, 1 times 6, that one's easy. But I'd encourage you to go over on the side and take the 43, because that's what you're going to be multiplying by 2, by 3, by 4, right? So take the 43 over on the side and find out what 43 times 2 is. Find out what 43 times 3 is. Find out what 43 times 4 is. And find out what 43 times 5 is. That's as far as we need to go, huh? Because there is no 6 in base 6. So figure those out in advance, and I think this problem will be a lot easier for you. So get those in base 6 first, and then dive into the long division. I'll give you. Okay, so here we go. So 2 times 3 is 6, but we can't write a 6 in base 6. Instead, we carry away 6 with none remaining, huh? In base 6, whenever we carry, it's 6. Then 2 times 4 is 8, add 1 is 9. That's carry away 6 with 3 remaining. Good so far? Next one, 3 times 3 is 9, but we can't have 9. Instead, we carry away 6 with 3 remaining. So in base 6, whenever we carry, we're taking away 6. 3 times 4 is 12. Add 1 is 13. 13, I'd like to put 13 here, but we can't do that. How many 6s can we carry away from 13? 2 of them, huh? So I'm going to carry 2 6s away. That's 12 with 1 remaining. 2, 1, 3. We good? Let's keep going. 4 times 3, don't come down here. 4 times 3 is 12. That's 2 6s, none remaining. 12 is carry away 2 6s, none remaining. 4 times 4 is 16. Add 2 is 18. 18. 3 6s. Right? 3 6s is 18. None remaining. Good. One more. 5 times 3 is 15. Over here. 15. How many 6s can we carry away? 2 6s. That'd be 12. That leaves 3 remaining. And 4 times 5 is 20. Add 2 is 22. How many 6s can we carry away from that? Yeah, carry away 3 6s. This is 3 6s and what, 4 left? 18, 4. So 3, 4. Got those all ready to go, so that should make my division much easier. Everybody good with all those? So again, we can see that dividing absolutely requires the knowledge of how to multiply well, huh? That's why I'm personally so opposed to social promotion of kids, especially when it comes to math. It's just so hard on them. All right, coming on over. So when we do the long division now, we can't go 43 into 23, so we go another digit. 43 into 233. How many times? Get these out of the way here. So we just look at our different results, huh? You look here, you look here, you look here. And you look there. So which is the one just under 233? 213, huh? It's 300 bigger. So 213 is the biggest thing. That's it'll go in 3 times, won't it? Making sense? See what I'm saying there? So it'll be 3. Now where do you write the 3? Now remember the placement, and I think it is helpful to do this, when you do the problem, especially for kids when they're first learning it. Yeah, so where do I put it's going to go in 3 times. I put the 3 over where? Yeah, this 3. The last digit of the number you're going into. Y'all aware of that? So this is, you write that. It goes over the last digit of the number that you're going into. So we're going into 233. So I go over the last digit, the 3. Okay. So now, and we know that 3 times 43 is 213. So I just write down 213, and I subtract. That leaves 0 and 2. That was good. What do I do next? Bring down the 4. You can bring them both down if you want, one at a time. There's no rhyme or reason. Either way's fine. Either way's totally fine. You can bring everything down at once if you want. You don't have to. You can just bring them down one at a time. Whatever. Okay, so next step. Good to there so far. So next step, how many times does 43, what are we going to go into? We can't go into 20, so you go into 204. Right? So maybe it would be better to bring it down one at a time. There's nothing wrong with it, but if it's easier for you to just see it, and it might be easier for kids to see it this way when they're new to the whole thing, just do it one at a time. So I'm going into 204. How many times does it go into 204? Yeah, 213 is too big. So 1 3, right? Finding the biggest number that you can go into, that'd be 2. 2 times it. So I'll put a 2 up there. 2 times 43 is 130. 130. Subtract. That leaves 4. And now I'm going to have to borrow, right, for my subtraction. So what am I going to do? I can't put 2, put a 1, and I borrow how much? 6, because we're in base 6. So 6 is added to that. 6 plus 0, 6 minus 3 is 3. Good to there. Bring down the 3. What could be easier? There it is. 5. So we go. 5 times 43 is 343. Done. Answer 325. Did you show this math to your friends and family? I think this is craziness. Like, what do you mean? 3? Just looks like insanity, doesn't it? It's all a different base. Is that good? Questions I can answer. I think we try one more. I'm getting a little tired of this all now. I don't know how you're feeling. It's been fun for a while, but we've been on this foreign base stuff forever. I'm ready to do something different. Let's do one more, like a base 2, but you let me know if you want to see more. Yeah.
This stuff, and I didn't if I put 4 and subtract 300. I was wondering, is there another number that you could add, like that has it could come up to the same number, but it has decimals?
Say it one more time. What's up?
It could come out to the same number, but it'll be a decimal number. It'll be.
Are you asking, is there another answer that's right or true?
Yeah.
No, that's the only answer.
Okay.
Any other answer would be wrong. Yeah, there's no other way to write that, in other words.
Yeah,
that's right. Is it making sense why it happened or where it happened?
Yeah, that's right.
You see it? Yeah. Yeah, there's no other way. Yeah. Right. Yeah, these, we're not going to give you any remainders. That just get too ugly. So there's not going to be any remainders and all that kind of thing. We'll talk, but it's a good question to bring up about decimals and all that. We'll do some of that later. Later, I don't know, a month or something from now, we'll be doing decimal. We'll be in a decimal section. We'll talk about fractions and decimals and how fractions become decimals and why they do that, and we'll get more to that. But you know, generally, since we're doing a long division problem, you know, if you had more to go, like if there was a remainder here, then what you could do is put a decimal point, a 0, bring down a 0, and keep going.
I think the next homework assignment has remainders, that's fine.
Does it?
Yeah.
Okay, maybe I'm forgetting something. Let's take a look at it. Well, let's do one more of these. I think we need to do a base 2. It's going to be like easier, because there's only 1 and 0, you know, or harder. It might be easier, because there's just 1 and 0. I don't know, it's always a little weird. So let's try base 2. Long divide in base 2. Let me double check it. Did I get that? One right? Oh, yeah. There it is. Okay. So give that a go. So I would again, you know, first off, you want to write it in the traditional way. Like that. And give yourself some columns there. And then over on the side, I would get ready. Well, actually, there's nothing to get ready. It's just 0 and 1. I mean, you know, I think it's going to be easier. All right, let me let you do it. All right. I think it might be easy. Let's see. So how many times does 10, what's it going to go into? It's going to go into 11, huh? Well, 1 time. Right? Subtract 1, bring down the 1. Yeah, this is easier. So lower bases are easier. Higher bases are harder. All right, 10 into 11, 1 time. Notice it's still all lined up, huh? Like I'm going into 11, so I put it over the last digit of the number I'm going into. That'll always be the case. So 1, 0, subtract 1, bring down the 0, 1. That was cake, because it's just 1 and 0. So higher bases are actually the harder ones. I thought that might be more tricky, but looks like no. So the answer is 1, 1, 1, base 2. We good there? All right, so I'm going to leave. If you're okay, I can't